Okay, so I guess that we're on. Um, hey everyone, thank you so much for joining. I am Maria, I am your host for today, and I'm from Portugal. I work at DevExperts Portugal, and yeah, I'm happy to know that there's already some comments, already some people saying where they're from in the chat. Welcome all. If you haven't said where you're from in the chat, please let me know because I love knowing where everyone is from. I can see here some people from Porto, Portugal, North Macedonia. Oh, that's nice. Okay, I don't think we've ever had anyone from North Macedonia, so welcome, Simona. More people from Porto, Portugal. It seems like this is the main location today for now. You're going to be the first ones to know that we're going to have another backend event, this time at our office in Porto in October. So we will announce everything on our social media today. So just stay tuned. There are also some people from Serbia, again, North Macedonia. That's nice. Georgia, Kosovo, Lisbon, Portugal. Wow, Albania. This is nice. This is really cool. We don't have offices in these places, so we usually have more people from, Porto, Portugal, and Tbilisi, Sofia. So it's really interesting to see that there are so many people from other locations. Bulgaria, well, that makes sense. We have, as I said, an office there. Um, yeah, that's pretty cool. Thank you guys for letting me know where you're from. You can still write in the chat because I will be paying attention. But I just wanted to introduce you guys to DX Tech Talks and of experts. DX Tech Talks are a series of free tech meetups that are organized by DevExperts, which is an international fintech company. DevExperts specializes in the development of financial software solutions and services for the global capital market industry. We were founded in 2002, and the company has R&D centers in Jersey City, Porto, Vilnius, Munich, Dublin, Tbilisi, Sofia, and also Istanbul. We started this project a while ago to be in touch with the tech community and to share our expertise in fintech and discuss some of our projects, our technologies, the tools that we use. Besides these online events, we also organize in-person events in Portugal, Georgia, and also Bulgaria. If you want to stay up to date with our events, like the one that we're dropping today about Backend in Porto, you should follow us on social media. We're on Facebook, Instagram, LinkedIn, Meetup, whatever you want, we're there. So you can just follow us to stay in touch and learn about some upcoming events that we have. We will announce everything there. So, about today, we have in program two tech talks. They are around 20 to 25 minutes each, and at the end, we will have time for a Q&A. So, if you have questions for our speakers, feel free to ask them in a chat. I will then read them to them and they will answer. Okay, so I guess that we're ready to start then. Our first speaker is David. David is a Java backend developer and he's a team lead at DevExperts. He has over a decade of experience in software development and he is a master of implementing efficient solutions. Today, he's going to tell us a little bit more about his work and then about market data distribution. So, David, welcome. I hope that you're ready for this. David has already presented his talk at the dxTechTalk conference in Porto, the first one that we had, and it was a huge success. So, David, please take the stage, and I hope you guys enjoy it.
Thank you, Maria. Let me share the screen. Can you see it? Is it
Yes.
okay? Okay, so let's let's get started. Hello everyone. My name is David. I'm a Java team lead here at DevExperts. I'm very happy to be here with you today, and we're going to discuss market data scalability, how to distribute codes in real-time systems. So a bit about me. Um, I'm 37 years old, a Brazilian software engineer for more than 12 years. I have a master's degree in distributed systems, and since ever, I'm Java backend. Um, Our agenda for today is we're going to discuss a bit about the context and why it's important for fintech, um, some building blocks, and then we're going to discuss publish subscribe architecture, how it scales, some challenges, then at the end the summary, and then you finally can ask me some questions. So let's go. So why it matters, why it's important. So you may know that quotes change very, very fast, and traders rely on this up-to-date data uh, because with that they can make better decisions and increase their chances to sell and buy. And while stale data can frustrate or cause loss, it's a lot of money. Um, so let's put this in an example. So imagine that we have uh, a system with some microservices, uh, some clients, let's say a browser here, and also a mobile app, an API that's serving data for robots. That's that's why R2D2 is here. Um, and those microservices you can make we can make sorry, you may have many, but here I just showing like four, just for an example. And all those microservers wanted data to calculate or to generate alerts. So let's imagine and let's assume as well that we have a market data provider like external to our system, like a third party that can retrieve data from stock exchanges and give the codes to us, like send us. And we are not going to discuss how market data provider and our system communicate, but we're going to discuss uh, how we spread this data over our system. So what we want at the end is every component receive those codes uh, real time, and because they want to calculate their thing, do their job. So margin calculator to calculate margin, alerts to depending on some thresholds on codes maybe, and even the client gator can make want to have this codes to so users can pull this data and see in their phones. Uh, so how can we do it? How can we continuously distribute these codes? Let's discuss some building blocks here. Uh, And then at the end, we are going to answer this question: should I implement those self-managed delivery? So first one, it's probably you already know, you already implemented one day in your life. It's polling. Uh, with polling, we have a client and a server, and the client continuously send requests to the server asking for updates, and the server will respond these requests with the data. Um, but you can see here, you may notice in my image here that those two answers, those two responses here are the same. And it can happen with polling because uh, if the polling interval is short, very short, then uh, it then server can sorry, it's the opposite. If the polling interval is too large, uh, user can miss data, while also they can receive repeated responses. Let's discuss something else here because the cost for polling is high uh, regarding opening and closing connections constantly, and it causes latency under scale. So one way to solve this problem is use WebSockets. WebSockets means that client has a persistent connection with the server, and this connection is kept open for a long time. Whenever there's an update in this data, server will pull this update through the same connection. Doesn't matter how many updates uh, we have, server will push this data through the connection. Uh, it's very good actually, and good for our what we want. But if you try to implement that by yourself, you see that manage those connections can be very, very tricky, especially under high load and uh, under scale. So another thing that we can do is webhook. Webhook is another technique where we don't have more opening and closing connections anymore. We don't have a persistent connection anymore. What we have is client expose an endpoint. So clients can send a message to server saying, oh, give me the latest updates and please answer me in this address, in this endpoint, like a mailbox. And whenever there's an update, server can call, send a request. It's not an answer to a request anymore. It's a request from server to client. So it means that the client has to expose a socket, a port somehow. And it's better in some cases, but imagine that not not all clients can expose a port. Imagine a mobile phone or something. So also manage these retries and keep track of each one is each port can be also tricky to implement. So what all those uh, all those approaches have in common, they're very hard to implement under scale. So this direct delivery struggles. And how PubSub can help with that? Um, First, uh, PubSub, in PubSub architecture, we don't have client and subscriber anymore. What we have is we don't have clients and server anymore. We have is subscriber and publisher. And what's the difference? Remember that all those pictures that I showed before, clients knew their servers and they kept the reference to the server, let's say. And here, subscriber doesn't know about the publisher and the publisher doesn't know about the subscriber. They are totally separated. They talk with a special component here, that's the broker. How it works? It works the following. Subscriber sends a message to the broker saying, hey, I'm interested in this topic, in this update, let's say Apple prices. And then broker will keep track of this subscription uh, for this topic. Let's say that this broker has one topic uh, for symbol, let's say. Then whenever there's an update in this Apple price, the publisher will publish this data, will send this data to the broker, and the broker will take care of notifying the subscribers. So let's put it in our example. Remember our example? So we have this system here with some microservices that need to receive these codes in real time. And we have also the market data provider. I'll not talk about market data provider anymore. Let's focus on our systems. So I added two new items here. Uh, Market data consumer, the one that will receive data from uh, market data provider. And let's say that it is our publisher, the one that has the information, the source of information, and the one that will publish these codes, this data that we need internally in our system. So it's our uh, external, it's our border, it's our external door, let's say, where we receive those data. Um, okay, so first thing is subscription. So every component should subscribe to some topic, let's say Apple prices or Tesla prices or whatever topic they want, even more than one. And broker will keep track of all those subscriptions. And whenever there's an update in these codes, publisher will send a message to broker just once. So not send a message to all the clients anymore, how manual approach did. And then broker will take care of an out, spread these codes over our system. So pub subscribe handles delivery uh, in a way that we don't have to take care of the heavyweight. We don't have to take care of, oh, sorry, we don't have to take care of the hard part, I mean, manage the connections. Um, so how can we scale using PubSub? I mentioned that previously with the other approach in ad hoc implementation of them, uh, we should concern about multiple issues, including scalability, because it's very hard to keep track of the connections. How PubSub does that? So first, we should keep in mind that publishers send data only once, not as client-server architecture, where publishers, depending on how many consumers exist, publishers should send like a lot of messages. The broker is the one that spread this data to the subscribers, and it's very important here. Publishers don't know about the subscribers, so they are totally separated. Uh, and this point is the most important, so you can scale publishers and subscribers independently. So let's go back to our application, to our system. Um, we can easily do something like this, like replicate our servers. We will not be concerned about scalability here. I mean, to keep track of stateful data or whatever, at least uh, not now. And doesn't matter how many margin calculators we have, all of them can subscribe to the broker. You even can divide this load somehow. Maybe one margin calculator will calculate one symbol, the other symbol, and the other more symbols. Can have the most heavyweight symbol to one and the rest for the other. You can choose. So every component can subscribe to the broker, and we even can have multiple publishers uh, that will also publish to the broker, and the broker will take care of the heavyweight. So how about the broker? Because if you see here, I have multiple components of my microservices, but I just have one broker, so it's a single point of failure. Let's see how we can scale broker. First thing we should keep in mind techniques as horizontal scale. You can cluster brokers. You can create partitions, replications, load balancing, charging. Every technique that I mentioned helps to scale and helps in one part. But As you may know, we always have to choose one aspect over the other. As an example here, a Kafka cluster, how Kafka handle broker clustering. Um, Imagine that you have here 3 brokers, but to the consumer's point of view, we just have one. Those brokers are replica. We have uh, the same topic as you can see here in the 3 brokers and 3 partitions. And in each broker, one partition is the leader and the others are the followers. So whenever we have one of the brokers uh, down, let's say this third here, uh, where partition choose the leader, another broker will assume uh, this role. Partition 2 in, let's say, first broker will become the leader, and that's why we have really resilience. Um, Now let's discuss some common pitfalls that we can face. So, as I mentioned, uh, there's no silver bullet in IT. We have to choose. We have to choose, always choose about 2 options or more than. Um, so why? Because the coupling messages increase a lot the complexity. So in this case, we removed this complexity from our components and best moved this complexity to the broker. What's better for us? um, so that's why we really need good tooling and observability. So some challenge that we have with PubSub, and to be honest, this first one with any distributed system is you have to keep in mind the CAP theorem, uh, which means consistency, availability, partition tolerance. We can't have the 3 at the same time. You always have to choose 2. And generally, we have partition tolerance. So in practice, we have to choose between consistency or availability. If you have consistency, we will not have availability, and the opposite is also true. So we have to choose, have to deal with this problem. And what's better, depending on your application, your domain, uh, you can have like high overload and back pressure, uh, delivery guarantees if you want that this data is delivered like only once, or you can accept like duplicates. Also depends on your domain. Access control, again, observability. And one uh, very important here is this one that I would like to present you quickly, the fan out challenge. Uh, what's that? So imagine that the number of subscribers are increasing, and broker will have like a hard work to do because they have to it has to send message to all of them whenever we have uh, an update. And if the application has low latency expectations or custom filters, you also increase the load on the server. So what to do? First, observability. Again, you have to monitor the aspects of your server, of the broker, how many subscribers you have in each node, uh, how many topics, partitions you have, uh, and also about machine, memory, network, and other stuff. Always go to this horizontally scale, and also you can use geo distribution, broker federation. That's another kind of uh, geo distribution. Also, you can compress message to decrease the load on the network, and also do some filtering on the client or in the server. It depends to also decrease the load. So as a recap here, uh, fintech apps must scale and deliver in real time. We discussed it a bit why. Request reply solutions developed manually have issues in scaling. So have to deal with connection and other stuff. And pub sub addresses most of those issues. Um, why? Because the publisher and subscribers are loose coupled. They're separated. We have a lot of challenges as you saw, especially this massive fan out. So I just would like to show you some implementations that you may encounter with about pub subscribe, including Kafka, Redis, and our QD, code distribution system, is developed here at Dev Experts that is specializing in codes, and there is a lot of improvements about performance in focused on codes data. So by the way, we'll have a presentation about Kafka after mine, so stay tuned. So I'm ready for questions, and you can also reach me out in LinkedIn and GitHub. Thank you, everyone.
Thank you, David. That was great. As always, I'm not surprised. I do really like that you added some superhero images and things. I thought that was super interesting. I'm not a tech person, so I don't really understand much about tech, but the fact that you used the the heroes and everything was really, really catchy. So thank you. We already have some questions and some comments. Some people said that, nice talk, well done. We do have some questions, so I will start reading them out.
Mhm,
There is, not for you, David, just one person that asked to discuss a bit further on a single on a topic. So if you have a specific question, I'm going to ask you to put it there. Otherwise, it can be a bit harder for David to answer. So, David, first question is, what problems could happen if some subscribers are much slower than others?
Okay, actually, it's a good question. Depending on the implementation, as the full answer for an engineer. Um, Why? Because depending on the implementation, you can have subscribers connecting to the server, or you can subscribers pulling to the server. Imagine Kafka, for example, uh, it works with subscribers pulling data on the server. So, and Kafka keeps track of all the data, and subscribers will have to keep track of how many messages they already read, and we don't have this problem even if we have a slow subscriber. But if you are using like a totally stateless pub sub, and where the broker has to send message to each subscriber, it can be an issue. So again, have to monitor your system and decide which implementation is better for your case.
Okay, cool. Thank you. There are more questions. I will just answer someone that asked if the recording of the broadcast will be here. Yes, it will. So you don't have to worry and you can watch it later if you want. Back to the questions for David. Could you briefly highlight the key differences between Kafka and RabbitMQ and when to decide for one over the other?
Yes, Kafka, as you see, you see more about that in the next presentation. Uh, but I will see that's more general purpose as I see. So Kafka keeps track of a buffer, and to not lose messages, it's nice, but it's also a challenge to replicate data. Uh, I see RabbitMQ used a lot for uh, these sensor networks where you can lose some data, and we don't have problem with that. Imagine that we have sensors capturing data from the environment and sending those data to a server. If you uh, lose in this second, you have it in the next second, so no problem. So it really depends. I would say to start with Kafka because I think it's more general purpose.
Mhm. Okay, cool. Someone also asked, what are your thoughts of using MQTT?
Um, I never used, but also it's another one that's I see used on those networks with sensors, everything. It's as far as I know, it's very lightweight, but unfortunately I never use it, so I can't go further. But yeah, nice one. I'll take a look.
Okay, cool. So we have two more questions. One of them is, are the filters implemented on server or client side?
You can have both, actually. In Kafka, if I'm not mistaken, it's on the client side. Uh, but you can also implement in the server side depending on the vendor that you are using. For example, QG, our product, by the way, it's open source. You can go to our GitHub and take a look. Um, in QG, you have the situation where, let's see, uh, on Kafka. Sorry, I missed the question again. I was
Sure,
talking about
don't
QG.
worry.
Can you
Are
repeat it?
the filters implemented
Oh,
on server
filters.
or
Yes.
client
So
side? Yeah,
I suddenly forgot
don't
what
worry.
I was talking. Um, filters. So with QG, you can implement filters on the server side as well. In the moment that you are establishing connection and subscribing to symbols, you can set filters. So it will be filter and you also can be on the client side. So in server side is good in a way that it will reduce data through the network, and in client side, uh, we will have this high traffic anyway.
Okay. Awesome. So one last question, because unfortunately we don't have that much time. If your question isn't answered, you can send a message to David on his LinkedIn or something. I'm sure that he would be happy to answer. But we had someone say that they didn't really, if you could discuss it further, and the single point failure in pub sub architecture, as they didn't quite understand what you were talking about in the single point of failure.
Okay. First, what's that? What is a single point of failure? It's when you have just one node, for example. You have a server, you have a service that's running. Let's say that you have a website and you have a backend and you have just one. What happened if this server is down? You don't have the service. People will uh, type your URL and will see nothing. You see an error, connection refused maybe. Uh, because this service, this backend that you have is your single point of failure. So whenever you have a component that, imagine that this component is down and the system can't work anymore because of that, it's a single point of failure. So at the beginning, I was showing how to scale components, and I showed that we can scale independently, publishers and subscribers. But how about the broker? Because until that moment, I just showed one broker. So imagine that broker is down. I don't know. There's a fire in the data center, and broker is down. Uh, where publisher will publish their messages, from where subscribers will receive messages. So in this case, a single point of failure. That's why you need to scale broker as well, using some of those techniques that I mentioned.
Great. Okay, thank you, David. It seems like Lydia, who was the person that asked this question, is now clear. So thank you so much. As I mentioned, we don't have more times for questions, but if you want to ask David some questions, you can reach him out and he would be happy to do it. I am talking on his behalf, but knowing him, I don't think he would
Yes,
have a
you're
problem.
right.
Okay, thank you so much, David.
Thank
So
you.
now we're going to move on to our second speaker. His name is Dmitriy Skroba. And Dmitriy is a Java backend developer here at dxTechTalk. He has so many years of experience building production systems and has worked with a variety of different industries. And today he's going to tell you a little bit more of his experience with fintech, more specifically with Kafka, which David has already mentioned. So, Dmitry, welcome, and you can take the stage and let us know all about Kafka and how not to lose messages.
Yes, thank you, Maria. Hi again, everyone. I'm Dmitry. Today I'll tell you, or we'll discuss how to use Kafka without losing messages. In the beginning, a little bit about myself. My name is Dmitriy Skroba. I'm programming for 5 years, and currently I'm Java developer in dxTechTalk, working on some trading platforms. Small plan for today. In the beginning, we'll dive into our context, then discuss technologies that we are going to use. We are interested in Apache Kafka and PostgreSQL in some of their aspects. Then we'll talk about simple solution, what problems it has, and discuss existing solution for our case and why we don't like to use them. And then we'll talk about transactional Outbox and develop our own with different approaches and discuss their advantages and disadvantages. And at the end, we'll talk a little bit about scaling. So let's start. A little bit of a context. We are the service that owns some business entities, and we have our clients, consumers, and they're updating our business entities. And when one client updates an entity, another one wants to receive an event about this update. So to do so, we put between us Kafka, queue for the messages, and now we need to understand how to properly use it. Yes, and before we can do so, let's discuss our technologies. We'll start with PostgreSQL, and we're really interested in one of its aspects, and it is a process called vacuum. What it is doing, it's getting rid of old entries. PostgreSQL uses MVC pattern to work in concurrent environment. It means that it creates several versions of one entry, and we need to clean them sometimes. Postgres has 3 types of vacuum. Classical one, it deletes dead entries, updates statistics, clear indexes, but does not return space to operational system. Second one is full vacuum. It's a big process to maintain database integrity, and it blocks block tables, compact them, and return space to operational system to be reused later. And for us, the process that will be problematic for us, it's auto vacuum. It's automatic by the name, and it started when some threshold is reached over data entries in our database, and it triggers vacuum and analyze after it, and could perform database performance in a bad way at the moment. So next, Kafka. We're really interested about guarantees it provides us. There are 3 of them at most ones. Unfortunately, we don't have any guarantees of the delivery, so we couldn't use it because our clients won't receive the messages. Second one is at least once. We guarantee the delivery, but to do so, we need to have some retries. Because of that, we could have some duplicates of the messages, but it's not big of a deal. Third option is exactly once guarantee. It's a tough guarantee to achieve because we need to set up not only our provider, but consumer too. And because of that, that we couldn't guarantee consumer to be correctly set up, we'll be using the second option at least once. And to make life of our clients a little bit easier, we'll send them identifier, version, and timestamp of the event so they can process duplicates on their site with their own logic. That's all about technologies. Let's talk about simple solution. Here it is. We save our business entity and then send an event about this to Kafka. And there are some problems. If you are like new into development, you may be surprised. But if you are really experienced one, you know that before implementing such solution, you must answer next questions. What if database is broken? Do we need to send an event to Kafka? Or if Kafka is broken, do we need to roll back changes in our database? And how we will work with Kafka delays, because to send an event to Kafka, it takes some time, and we also could have some network issues, and we need to work around them. All those questions are questions about consistency in distributed system. And there are several ways to achieve it. One way is change architecture. We could use Actor model, Saga, CQRS, but usually to do so, we need to rework our code, and usually it's quite pricey, so not an option for us. There's other option, technological one. One of the examples is CDC or change data capture. Let's discuss it, what it's doing, how it works. CDC tracks changes in your database and send events about those changes into the staging area. It could be anything, Kafka or data lake, to analyze those data later. In any case, it seems like something that will work for us. Some of the examples of CDC is Debezium, one of the most popular one. Second one is Oracle Golden Gate. It's good because it has zero impact on database load. It's achieved by analyzing file log and quite good. Only disadvantages of it is that it works only with Oracle database. Also, I must say that almost all cloud providers have their own solution, like DMS from AWS, to this solution supports some of CDC features, and you could use it. So why couldn't we use them? All of them have several problems. One of them, they are all instruments for general task. And because of that, they're hard to set up in quite restricted scenarios. For example, if you have normalized entries in database, you will have inconsistent state in Kafka because CDC doesn't know what's happening with your business entry. It only tracks changes in one database, in one table. Sorry. Also, it's CDC, it's a black box, so we don't have any guarantees over delays. We could like stop receiving any events to Kafka, and the only option we could do it's like to fix it. We could restart CDC and hope for the best. So if all those problems are impacting you, you can think about using transactional outbox. What is it? It's a pattern that ensures that you have a way to reliably save events and publish them without risk of inconsistency. I found out about it in this book design data-intensive application. If you haven't read it, please do if you have some time. It's quite a good book. So how this pattern works? It's quite easy. You have a main process where you save your business entity into a table, and in the same transaction, you save an event to Outbox table, and then you have another mailing job that reads from Outbox table and send events to Kafka. So you basically segregate responsibilities to two different jobs, and if anything, you can scale them independently. So let's try to implement our own Outbox. First of all, we need a table. Let's call it Outbox. But before we continue, we need to think about how we will delete entries from this table, because we don't need to like have events there indefinitely. After we send them, we could delete them. And there's a question: what is the best way to delete entries in PostgreSQL? And the right answer is using partition. And it's quite useful to create, in this case, partition by time, because in this case, we could like delete all the messages from last week at once. Quite easy. But we have one problem. PostgreSQL doesn't know anything about partitions by time. And to address this problem, there's two solutions. One of them is timescaledb. It's an extension. And also you could do it yourself, like create some cron job in your application that will create partitions for you. So with this, let's discuss our next steps. First of all, we have three topics: how we will write into Outbox, how we will select from it, and how we will send events to Kafka. So let's start with writing. You can do it by hand, like an own villain. It's engineering task, so quite solvable in our case. Or if you are using some framework, you can use AOP, proxy, or set up own processor if you're using object relational mapping. So yeah, that's all about writing, not so much. Let's talk about selection from Outbox, because there are quite some options how you can do so. So first of all, you have queue of events, so you can use queue in database, syntax select for update. We should skip locked entries to prevent like being stuck on it. Our SQL query will be looking something like this, and Java code like so. We need transactional annotation because all this should happen in transaction. And could you spot a problem in this code? Like there is several one. One of them is that we'll have long transactions, because not only we select entries from the database, but we also send them to Kafka, and it's not very fast. Another one is that we are locking entries in a table. And if we have too much locks in a table, Postgres could lock the whole one to prevent overload, and we'll have problems in our main process that operates with business entities. It will be unable to insert any new events, so it's not very good. We should think about something else. And what we can do, we could create our own queue on statuses. So we'll add new column called status. It will have three options like of the value, new, locked, and send. For fast selection, we could add index for it. So how it will work? Our select will look something like this. We update events and return their IDs, and they are locked for us to be sent. Our Java code will look like so. We select, send, and then mark them. But before we continue, we must remember that we are working in distributed systems, and sometimes our systems can fail. And if we fail in between, while, for example, sending an event, our events could be stuck in locked state. So we need an additional job to send messages that get stuck. Yeah, that's as so. But this solution still have a problem because of us changing status at least 3 times, like from new to locked and to send. We have like changeable state in database. So MVC pattern in database will be triggered, and this will trigger a vacuum that will reduce performance of our database. If we want high availability, we'll have problems with this, and we will need to think about something else. But apart from that, this approach could work. Yes, so if the previous approach is working for you, you can think about shifts. And what is it? We could add another table, like where we save the batches that we have already sent to the Kafka. And how it works, we have events through time, and our job took one batch, send it, save that we have done it, send another batch, and so on and so forth. And Java code will look something like this. So we have a counter, we increment it, get events by the counter, and update it in the database. And it looks like we could use ID of our events, like, use sequence or big serial for it. But we must be accurate because our applications are smart, and usually they cache IDs, and we could have next problem when we send the batch of all events that have ID less than 20, but we cached a value of ID 18 and insert it later, and then it is forgotten for our client. That's not good, but we could address it by forbidding caching of IDs. But the next problem is quite hard to solve, and it's called long transactions. By any means, transaction could be prolonged by like long network connection or other problems. So we could start a transaction, commit several ones, even send them to Kafka, and only after that commit the first one. In this case, first transaction, an event it contains will be forgotten for our client. How we can fix this? There's not so many options. One of them is to increase isolation level to serializable, but it's not very good. We'll have one threaded application, and yeah, not very scalable. Another approach is to have distributed lock or synchronization on inserts. It will be a little bit faster, but still our main application that work on a business process will be quite slow. So we could try to use something else for shifts, and we already have creation time. Let's use it. Our select query will look something like this. We need some buffer time. We'll talk about it on the next slide, why we need so. And we could use approach with time, but we must remember next things. Usually on different machines, we have different time. It's known for quite a while that we have delays in the network, and also the time differences. Because of that, we need some buffer to not forget some events. Also, we must remember that like twice a year or a bit frequently, we have time synchronization. So we should be accurate with this too. but this approach is working, and yeah, we could use it. So let's talk about sending to Kafka. Could you spot a problem in this code? I showed you before. We have a counter, we send an events, and I must say that the problem is with the method send. It doesn't really send an event right away to Kafka. It just puts it in records accumulator that is controlled by Kafka producer. And what is it? It's a buffer that is stored on app heap. So why we do so? Because Kafka wants to be efficient, and to be efficient, you need to send events in batches. We could control this buffer in some ways. We have 3 parameters for this. One of them is linger mass time. It is basically how long producer will wait before sending the batch of event that he already have. Another one is batch size. It's like a size in bytes of the data. If we exceed it, producer will send the whole batch without waiting for linger mass time. Also, there's a third parameter that controls when we block method send. So if we try to send too much events and Kafka producer won't be able to process them all, he'll just block the send method until buffer is flushed to Kafka to not get OM exception. So yeah, if we look closely to the method send, we could find out that it returns completable future. So we could guarantee the delivery by just like collecting those completable futures and waiting for them all to be completed before updating our counter. In this case, we can be sure that every event is sent. So that's all about our Outbox. Let's talk about scaling, how we can do so. And to be honest, if one job is enough for you, you shouldn't be thinking about scaling because it's quite tough. And just like perform some safety actions to be sure that only one instance of the application is running. You could use some library like Shadlock or Sprint Leader election algorithm to ensure that, and you'll be fine. But if one job is not enough for you, you could parallel stream of your events by like make partitions from this stream and send them to Kafka partitions. From the developer point of view, you need to like remember 2 things still: that you don't want to send duplicates of the events, and also quite important one, you don't want to break order or your client could get quite confused and angry. Yeah, but don't do so if one job is enough for you. Yep. You may ask, what about existing solutions? Do we really need to think about all of that? Maybe someone already created something for this. And to be honest, if we are talking about the whole process of inserting, selecting, and sending, no, there's no silver bullet. But if we are talking about selecting and sending, there is. It's called Kafka JDBC connector, and there's 2 types of those connectors. Source, that taking like information from database and putting them to Kafka, and sink, that do otherwise, like they are taking events from Kafka and putting to database. If we look closely on their documentation, you can find out that they could work with all scenarios we discussed previously. They could use increment to select events or timestamp, or you can even give them custom select query. Also, they could have additional options. And to be honest, like CDC is subclass of Kafka connectors, but Kafka connector is like independent one. Problems with this, like still, Kafka connector is a black box. So we could have problems with observability. When something goes wrong, it's hard to track what is going wrong. Also, Kafka connector stores offsets in Kafka. And if you need them, you need to read documentation how to get them, but it's possible. So, small summary. Context. We have changes in the database and we want to send events about them to Kafka. How we can do this? We could use existing solutions like CDC or Kafka Connect, and only if they're not like enough for your requirements. I know maybe they don't have enough performance or you need to have better observability. You could use transactional Outbox because you can set up as you like it and it works just right and it's flexible and like it could make your system consistent. Yep. That's all from me. Thank you very much.
Thank you so much, Dmitry. That was great. We do have a lot of questions already, so it seems like people are really engaged, which is amazing. Thank you all for that. A lot of these questions are two-parted, so I will start with the simplest one that is only one part and then go up to the others. I do want to let you guys know that David has answered some of the questions that we didn't have time to answer in the chat. So if you made those questions, all of the answers are in the chat. Okay, so moving on to your questions, Dmitry. The simplest one is why could we use CDC with Outbox table?
Good question. Like usually CDC is valued because you don't need anything to set up. Like you could work with database as it is. It will track changes and send events right away without any preparation. If you have your Outbox table, it's better for you to use Kafka connector. It's more lightweight and easier and simpler.
Okay, cool. So now we're moving on to the two-parter questions. How does Kafka handle caching in case of parallel requests for the same data across multiple subscriptions? And will it make requests to underlying data storage upon every sub, or will it maintain cache?
Whoa, it's quite big questions. Big question. In Kafka, we have like consumer groups, and we store like data that we already sent in those consumer groups. And to be honest, like Kafka will not send additional events if you already provided information that you received it.
Okay. Next one. In real applications, do you send some events not via buffer-based based stream? Let's say we don't need to guarantee every event to be sent, but only last event. Is this common use case for Kafka?
Yes, it really depends on like amount of data you have. If you have a very like data intensive application that produces a lot of events, to not load too much your Kafka, you could combine some events into one and send it not like 20, but one event. It could be done, but it should be done by you on your own site.
Okay, thank you. Have you worked on a solution for sending events sequentially by one key, but in parallel for different keys? If yes, could you please tell us something about it?
Could you please repeat the question?
Yes, of
I
course.
got a little bit confused.
Okay, sure. Have you worked on a solution for sending events sequentially by one key, but in parallel for different keys? And if yes, could you please tell us something about it?
So if I understand correctly, if we have one key, we should put it, like, for example, in one partition to be sure that events have an order. And if we have different keys, we could send them parallel in different partitions to improve our efficiency if we need so. That's if I understood the question correctly.
I think that's what it meant, but if it wasn't, Alexei, please just let us know and we will try and answer your question. In the meantime, let's move on to the next one. Who comes up with these concepts? Where to find the source?
If we're talking about transactional outbox, I'm not sure who was the first one to suggest it, but you could read it in like data intensive applications book. I'm sure that you'll find some info of creator of this pattern there.
Makes sense. Okay, we have only 2 more questions, and that will be it, so you can rest then. How can we instrument our Kafka application for observability?
Okay, we could add, for example, we could check latency. We could track like how long have passed time from us sending the message and us being able to receive it on other end. We could get some metrics from Kafka that it is providing, but over this, you might have some logs from Kafka, but yeah, not much else.
Thank you. And the last one is there any decision tree made visually about when to use pub sub or go for a simpler solution that you can share with us?
I think it depends on your load because it's quite simple. If you need PubSub, you will know it because your application won't work otherwise. You'll have problems with like your system not being good enough in performance way. And yeah, if you're good with other approaches like webhooks, you should stick with them until you will need PubSub approach.
Okay, that's great. Thank you so much, Dimitri, for your presentation and for answering all of these questions. I know that was a lot. And thank you all for coming to today's event. We do have another event happening about Backend in Porto on October 14th. So if you're in Portugal and you like Backend, we've already put it out on our social media, so you can go there and register. If you're not from Portugal, don't worry, we have a lot of events, so you can follow us on social media and you'll find all of them there. And we also have a call for papers going on. So if you want to be a speaker at one of our events, you can go to dxTechTalk page and you'll be able to register from there. And that is all. Thank you so much. I hope that I will be able to see you next time at another dxTechTalk, either online or in person. I'm usually at the ones in Portugal, sometimes also in Bulgaria. So I would love to see you in person or online on our next events. Thank you so much, and we'll see each other soon. Bye bye.
Bye bye.